Right, homework 4, we've got three different types of inequalities. The first one we can see x is in the middle, in between two values. In the second example, we can see that we've got conditions where there's two inequalities that need to be satisfied, and in part C, we've got two where the keyword is or. So that's going to be important. Let's go through these one at a time. So here, we want to solve this for x. So what we want to do is unravel this, I guess. So we want to subtract 7 from everything. So when we subtract 7, we get minus 9 here, 3x in the center, and if we subtract 7 here, we'd get 6. So this makes it a bit easier now. Now we can just, to get 3 by itself, we need to divide by 3. So dividing everything by 3, we have x by itself in the middle, and we can say safely that x is between minus 3 and 2. And we're also after, so we found it, we also need to graph the solution set. So let's draw up a little real number line here. These are our x values. Let's put 0 as a reference point, and we've got 2 over here and minus 3, and neither of those values are included, so we'll use a hollow dot above those values, and we're looking for the x values in between those as our solution set. So if we're going to write this as a solution set, we should probably say SS for solution set. We should say x such that x is here and x is a real number, just to be formal, because it does say the solution set here. Alright, so now let's look at part B. Here we've got two separate inequalities. So the first thing we'll do is take this inequality over here. So we say minus 2x plus 5 must be less than 3x minus 6. But also we have this second part here that says that 3x minus 6 must be less than x plus 1, and these both have to be true. So here we're looking at the special word here, and. Well, I should use the English there, and. Alright, so here let's just solve this just like an equation. So we're going to take our x's to the left hand side, we'll subtract 3x and get minus 5x, and subtract 5, get us minus 11. Now here's where it gets different. When we're multiplying or dividing by a negative, we'll have to reverse the direction of the inequality symbol. So we have 11 over 5 here, greater than. So that's the important thing. It's completely the same as an equation, except for those situations where you have a negative coefficient here to get rid of. So let's continue here for our second inequality. Subtracting x, we'd get 2x. Adding 6, we'd get 7. So x would have to be less than 7 over 2. Notice that dividing by positive 2, we keep the direction of the inequality the same. Alright, here, so now let's draw up a little number line. Important values. Okay, 0 is important here. Now, which one of these is the smallest? This is about 2. And what's this about? This is about 3.5, I guess. So the smallest one will be 11 over 5. And then to the right of that, we'll have 7 over 2. Right, so neither of those two values are included, so hollow dots for them. And so we have x bigger than 0.11.5, so that's going off to the right, but also less than 7 over 2, so that's actually going to be this region in the middle. Some people like to draw a little sketch here like this, something like to draw the two inequalities. That's x bigger than 11 over 5 and then x less than 7 over 2. But because of this word and, we look for the part that's common, and that's how we get our answer here. Alright, so now the very last part of our question. We've got two separate inequalities that we can solve. So we can have just adding 3, 6x less than or equal to adding 3 would be 10. And let's divide that by 6 and we can simplify 5 over 3. And for this second part here, or we can subtract 4x and get minus 7x. is bigger than 14. Again, we're dividing by a negative, so we need to reverse the direction of the inequality here, and it's going to be minus 2. X value is less than minus 2. So let's draw up our real number line, our x values here. So the important points, let's say 0 is a reference point, and 5 over 3, well, that's something less than, a bit bigger than 2, let's say. So if minus 2 is here, it's going to be slightly further away, 5 over 3, or slightly less, I should say. So it's slightly less than 2, that value, so let's make it a shorter distance, 5 over 3, because 6 over 3 would be 2. Now let's use our method that we used just above here. So included here, solid dot, everything, the arrow here is pointing to the left, so let's draw all of the values less than this value. Or we could also have this values here less than minus 2. Now if we combined both of them together, because both of them could happen, well, remember this or is inclusive in mathematics, so we're combining both of these. It looks like this value has to be included, as well as everything to the left. So there's our solution. Our final solution set is going to be x such that x is less than or equal to 5 over 3. X is a real number. Great. And we should also finish off the part B. I forgot to write the solution set here. The solution set here is x such that x is an integer. I should say 11 over 5, because these are in between these values. Between x is between 7 over 2, and x is a real number. This should all be in one line. I've run out of space here. More conveniently, we could write each of these in interval notation. So in interval notation, this top one would be, round brackets, because the values are not included, minus 3 to 2. This one here looks like it would be 11 over 5 and 7 over 2. And this last one here we could say minus infinity, because that's going all the way to the left, not included there, and 5 over 3 included.